You just caught me looking at this planet. Google really did a good job with this. But how hard could it be to create an effect like this? In this video I'm going to try to recreate a planet rendering like this in OpenGL. Also Java 13 and LWGL. To start off we have to write some boilerplate. But that's not very interesting, so I'm not going to show too much of it. Instead I'm just going to show you this black window. Since I plan to import this planet as a GLTF model, we might as well just model it in Blender. So here I am doing that very quickly. You can see me here translating it upwards. I also like to make sure the normals are correct, so here's how I do that in Blender. Since I'm going to be texturing this sphere later in OpenGL, I should make sure that the UVs are in there and that they are exported as well. Just for the fun of it, I made a test texture and made a render in Blender with that test texture. Finally, I'm saving as GLTF separate, so I get a short JSON file and a binary buffer file. Going back to the program now, we have to write some shader code to make this work. And I'm going to utilize the new feature, or the preview feature in Java 13 called text blocks, which allows me to write the shader code directly in the source code. This may not be a good idea for larger projects, but for this I think it's fine. I started with this simple shader to give the sphere a solid color. Soon after this I realized my export from Blender didn't include any image at all. It turns out Blender doesn't export the image in GLTF if you use the diffuse BSDF shader. You have to use the principled BSDF. After fixing this, the image and texture is now visible in the GLTF file. Now that that's out of the way, I can change the shader program in order to use the texture and not just a solid color. You can see the entire shader program is inside a text block, and you can see the result here. Okay, I think I'm ready to put a nicer texture on the sphere now, and for that I'm going to go to NASA's website. They have a very nice download of the Earth. I'm gonna choose PNG and just get it in the nicest quality I can. To make this texture work with OpenGL, it has to have a size that is a power of 2. And I just resized it to make sure that was the case. And there we have it. That's very nice actually for texturing the sphere. At this point I would like the planet to rotate not only around its y-axis but also around its x-axis. And I map this to keys on the keyboard, and then this happens. This happens because I translated the sphere in Blender. In order for this kind of rotation to work, the origin of the model has to be the origin of the geometry as well, if you want it to spin around the center of geometry. So here's me fixing that. And we can now see the poles. Pretty cool. This lighting is a little bit underwhelming, so I'm going to implement some fong lighting instead. I'm going to add a diffuse component and an ambient component. Diffuse component will depend on a light source, which is a vector that describes the direction the sunlight is coming in. After doing this, we see that there's a problem with it. The light source is rotating with the planet. And well, I didn't intend for that to happen. This is because I neglected to multiply the model matrix with the normals. To fix this, I just multiply the model matrix with the normals. However, there's a catch to doing this. If your model matrix includes scaling, then your normals will no longer be normalized, so you have to renormalize them. In this example I'm only doing rotation though, so the normals are still normalized after being multiplied with the model matrix. For reference, the shader code at this point looks like this. Now let's take a step back for a bit. I know my Earth texture has this 8 bits of alpha data that I'm not using for anything. And I also noticed that NASA has this nice download of albedo data, which describes how reflective the surface of the Earth is. So I'm thinking maybe I can cram the albedo data into the alpha channel of the texture. So here's a quick demonstration on how I got that data into the alpha channel using GIMP. Now that we have this data in the texture, I can rewrite the shader to check if there's anything in the alpha channel, and if there is, I can set the color to red. The idea is then to use this to control the amount of specular reflection that comes off the planet, so the ocean will reflect a lot of light and the green areas will reflect less light. Here's a clip from when I first implemented the specular reflection without the use of the alpha data. You can see there are artifacts on it, and that's because I used the normals in an operation and then I forgot to normalize them afterwards. Here's what it looks like with the normals normalized, and then finally here's what it looks like when the alpha channel data is being used as well. Finally, I'm going to add the Fresnel effect, which is going to make the edges of the sphere more reflective, as shown here in the Unity documentation. A cheap way to do this is the Schlick approximation, and that's what I'm going to be using. This is a pretty cool effect, but it's not what I'm after. This is the sphere lit from behind, and there's no other light than the Fresnel effect. So this leads me to believe that it is working as I want it to. And finally, here is the result. I think it looks pretty good, but it doesn't look as good as Google's. So that stuff's really difficult. I will let this play in the background while you consider visiting my Patreon. Thank you for watching.